So, as promised, here is the Pager Podcast Christmas special.
We asked our keen listeners to send in any Christmas-related questions that they had on their minds over the festive period. These range from the fascinating to the highly inappropriate.
Some of the more borderline ones have been kept in, and any complaints can be directed to pagerpodcast@gmail.com.
Right, well, with that out of the way, let's get started with the questions. So, George, I have one here for you. Do you really get a cold because it's cold?
Okay, so a bit of digging into this actually revealed that it's a little bit more of a complex and debated question than perhaps I first assumed. So one theory that many people have brought in is that spending more time indoors with poorer air circulation and with people perhaps with different viruses in their systems, and actually in close proximity to those people, it's just easier to spread.
So it's nothing to do with the actual cold, according to that theory?
Well, there are other theories as well. So the common cold is caused by a number of different viruses. One of them is the rhinovirus. So in over half of people in which a virus is actually found to have caused a common cold, it's rhinovirus as well. But there are other theories, as you perhaps alluded to. So days are shorter as well, and lack of sunlight during the winter, and because it's colder, people can go outside less, and this can lead to low vitamin D.
And does vitamin D have a role in the functioning of the immune system?
It does indeed. You took the words right out of my mouth. So vitamin D is produced in a process that's dependent on sunlight, and the vitamin D receptor is expressed on a number of different immune cells. And having low vitamin D can modulate your immune response such that you're more susceptible to viral infection.
Interesting. I wonder if you get more viral infections further north from, or in the northern hemisphere, further away from the equator.
Well, this actually, I'll touch on that a bit later. But there's another interesting idea as well, which is that the cold might actually be to play. So the rhinovirus in particular, and also the influenza virus as well, they tend to replicate better in colder conditions. So whilst your core body temperature remains pretty stable during the winter and summer period, you're great at regulating that at around 37 degrees. The temperatures in different areas, such as your mucous membranes and your nose, it can vary much more, and actually it's thought that this could perhaps lead to increased replication, capacity to replicate for the rhinovirus or the influenza virus when it is actually cold outside. So the idea that if you go outside with wet hair, for example, that could be perhaps why. But there's also another theory that comes with the cold. So another idea is that in breathing all this cold air in, this can lead to constriction of blood vessels to conserve heat around, for example, in your nose and in your pharynx, that's the upper part of your airway. And this constriction can reduce the blood supply sent to this area and therefore reduce the number of immune cells that can actually get there. So this might be responsible for actually the fact that you're not as able to fight off perhaps what is a subclinical infection. The virus can replicate and then spread to your kind of upper respiratory tract as well.
So I suppose the cold could be playing a role in two ways. Firstly, the virus is better able to replicate, and also your cells are less able to reach, like you said, those areas like your nose and your upper pharynx or your throat where the infection might be taking place.
Yeah.
Oh, interesting.
In addition, so winter is not necessarily correlated just with cold and low sunlight as well. It's also correlated with changes in humidity. So it's known actually that the influenza virus actually prefers drier environments as well, and it survives less well on surfaces that are drier, as well as preferring it to be perhaps a little bit colder than it is in summer months. And we know that from epidemiological data that after a dry month, flu infections in the month afterwards are actually increased.
These are studies of the whole population, or a large population.
Yeah, a significant number of people. And why might this be the case? So there's one explanation actually, that when it is humid, particles containing the virus come out of our mouths and they don't break up as much in humid air, and they therefore drop to the floor more, in contrast to in dry conditions where they become more of an aerosol and can spread around a lot more. Now, I think eager listening listeners will think, okay, hang on, I know a really dry environment which is on aeroplanes, and we don't see increased rates of colds and flus after the fact that people have been on aeroplanes. And there's not that good an answer to this. It's perhaps due to better filtration on aeroplanes as well. But I think the jury is out on this as well. And it's also another strange thing is that if you move away from the northern hemisphere, as you mentioned earlier, and you move closer to the equator, actually flu infections are associated with increases in humidity as well. And it's been thought that actually the virus might be able to stick to walls, but this is all there's quite a lot of speculation around it and quite a lot of uncertainty. And I don't think anyone has really got the answer for exactly why flu is typically more common in winter months. And whether you actually get a cold because it's cold or whether it's a number of other things as well. But the cold certainly can play a role in your susceptibility to flu infection. So another question that we had from one of our listeners was, at this time of excess, should we be restricting our calories to live longer?
The story behind calorie restriction is quite long and also very interesting. So people were onto this idea that restricting the amount of calories you intake over a prolonged period of time might extend lifespan, which can be defined as the idea in the literature that you reduce the calorie intake of an individual by more than 30% from their previously unrestricted calorie intake. And the story behind understanding calorie restriction is interesting and quite long. So people, long before there were sort of proper animal model studies, believed that restricting the amount of calories you take into your body could improve your health and potentially even extend your lifespan. We're obviously more selfishly interested in whether calorie restriction can extend human lifespan, but there's a lot that we can learn from experiments which have been done in animals, and a lot of different animal models have been used. In fact, everything from looking at yeast through to mice models, through to non-human primate models have been studied. And broadly speaking, the evidence seems to suggest that calorie restriction does extend lifespan, although there are quite a few caveats to this, and it's really unknown to what extent this can be extrapolated to humans, because proper studies looking at this can't really be done in humans for reasons we can get onto later.
So is this due to the fact that people in general are eating too much and we're bringing them back to a baseline, or is it that actually from a baseline calorie intake, which we'd see as perfectly healthy, reducing it to 30% less is actually effective at increasing people's lifespan?
It's the latter, which I think is very interesting. And I don't know how calorie restriction of that sort can be sustained over a very long period of time, being in a calorie deficit. But at least in the length of time that these studies have been done for, it seems that calorie restriction can extend lifespan up as much as 20% in mice. Now, there are other things which are sort of complicating the story here. So, for example, how does diet composition play a role? And does whether the human body is in a state called ketogenesis, where it's actually going through different sorts of metabolic pathways and preferentially oxidizing fats to produce these things called ketone bodies, does that play a big role in extending lifespan?
So that's when there's not enough glucose available?
Yes, exactly. And this also ties into the idea of intermittent fasting and whether or not eating within a short window during the day is beneficial for health. The jury's still out on that, although there's a lot of interesting anecdotal evidence. So what can we say for sure? We can say for sure that in everything from yeast to mice, calorie restriction seems to help us live longer. What we can't say is whether this can be extended to humans, because the data in primates just isn't really conclusive enough. But what I think is really interesting is that when we think about the mechanisms by which this might be happening, it's likely that it's certain proteins involved in metabolic sensing. So these are proteins within the cells which are telling the cell about the state of nutrients around it. A few to mention would be mTOR, which senses amino acids in the cell, and AMPK, which is on the cell surface membrane. And when you look at compounds which interfere with these processes, namely rapamycin and metformin, which is actually used as a diabetic drug. I spoke to Professor Franklin about metformin at quite a lot of length. These drugs seem to also extend lifespan. In fact, rapamycin, I think, is the only compound which has been shown to extend lifespan in everything it's been studied in. So potentially, these compounds could be used in lieu of some sort of calorie restriction to extend lifespan, although the data is not really conclusive at this point.
And perhaps going back to calorie restriction, is this necessarily something that we would want to put ourselves through? So 30% seems like quite a lot. In fact, and it might have some side effects associated with it, whether it's losing muscle mass, and we know as people age, actually maintaining muscle mass can be quite important to reduce things like falls as well and to maintain balance. And also the fact that actually we do need enough energy to go about our daily routines as well, to play sport, to keep our mental abilities in check. So what sort of lives are we going to be living with these actually quite heavily calorie restricted diet?
Yeah, it's a very interesting question, and it's hard for us to know exactly what sort of effects that sort of calorie restriction would have and to what extent it would be worth it. What I think is really interesting is potential future studies using something called Horvath's clock, which is a way that we can measure the biological age of cells, or so we think, by looking at the epigenetic profile of the cell, namely methylation at certain points in the genome. And perhaps we could subject people to different diets and different calorie-restricted diets and see over a period of time how that affects the way their cells age. Now, whether this clock is quantitative enough to do that at this point, I don't really know, but it could be something interesting to look at in the future. So, George, another question we've been asked. How much weight would Santa gain if he ate a single mince pie at every child's house in the world? And I had a bit of a think about this question. And I thought that if we assume that Father Christmas, or Santa if you will, doesn't eat the whole mince pie at each house, say he just has a bite, 100 calories, I'm estimating, at each home, and you can estimate there are about 1.6 billion households, I suspect that he would eat enough calories to sustain him for 64 million days, or 175,000 years. Considering he's been doing Christmas for however many hundreds of years, I would definitely say that he's in a calorie excess. One thing that I haven't considered sort of in any sort of quantitative way is what the effect of lifting all those presents must be, because that's a lot of weight, and he's probably expending a lot of energy to do that. And what the effects of that are, I don't really know. What do you think?
Well, I did have a dig into this. Sadly, I didn't factor in lifting presents it was a very long night and hundreds of millions of presents. But I did do some maths regarding how much fat and how much weight he might gain if he were to eat that many mince pies. So I'm going to assume that it is gained as fat, given the difficulty in gaining muscle or bone or other parts of the body at that rate. So let's assume that all the weight that Santa would gain is fat. So fat per gram contains about 9 kilocalories. So that's 9,000 per kilo. But given the fact that fat tissue isn't entirely fat, the amount of energy stored in a kilogram of adipose tissue or fat in your body it's estimated to be around 7,700. Okay, so good so far. So as you did as well, let's tackle it from the other direction. So how many children are there in the world? Well, one estimate says there are currently 1.9 billion under 15s in the world. Now, Santa does visit people who are older than this. I know that for a fact. But I find it hard to find statistics for people who are under the age of 18, but over the age of 15 as well. So let's just say that Santa visits people who are under 15, which is, of course, a gross simplification. Again, if we estimate that every household has an average of 2 children, if it has children, this gives us 950 million households. So a slightly lower estimate than yours, which I'm not sure which one is better, but let's just take 950 million households. And for the sake of simplicity, let's assume that all the children are good and would, of course, be getting presents. So next, let's have a look at what is in a mince pie. So Phages Podcast doesn't recommend brands. So all I can say is that a quick search on the internet for a standard British supermarket mince pie came up with one for £1.50 for 6, which had 209 kilocalories per mince pie. So this included 7.3 grams of fat and 13.7 grams of sugar. So put this all together and you get 950 million multiplied by 209. That's the number of calories in a mince pie, and then divided by 7,700, which is the number of calories per kilo of fat put down, which gives you 25.79 million kilos of fat that Santa will be able to put down.
George, that's a lot of weight. I don't think that's going to be healthy for his joints.
But of course, it's not as simple as that.
Oh, it never is. It never is.
So we're assuming that there's a 100% conversion rate from a mince pie to fat, which is pretty impossible. It's also true that the process of digesting and absorbing all of that nutrients is quite energy intensive. So protein is typically the most energy intensive macronutrient to digest. So about 25% of the energy within protein is actually required ultimately to digest it and to absorb it in that process. Though each mince pie that we had only contains 2.1 grams of protein, which is only about 8 kilocalories out of 209. So in contrast, sugar, which also has 4 calories per gram, made up 55 calories of the 209. Fat, meanwhile, which has a higher density, as we mentioned before, of 9 kilocalories per gram, made up 66, and then carbohydrate pretty much made up the rest at 78. So if we say that we might lose about 10% of the energy in food ultimately for absorbing it, that's 10% of the total as well. And also, converting fat to fat is relatively simple. You break it down into pretty much its two parts, so into glycerol and into fatty acids, and then you put it back together again in adipose tissue. And it's a little bit more tricky when it comes to carbohydrate. So if we assume that the transfer process from carbohydrate to putting it down as fat loses another 10%, suddenly we're eating away at that enormous pile of mince pies, and Santa hasn't gained quite as much weight as we think. So a bit of quick maths here. And I came to an estimate that each mince pie will only contribute 170 kilocalories, to fat, in contrast to the 209 if we were to simply stick it on a fire and burn it. So combining this with our original estimate of 950 million houses, and we get only 21 million kilos of adipose tissue put down, although that's before we consider supporting structures such as blood vessels, which are also needed. So ultimately, Santa might not gain as much weight as our original estimate suggested. And of course, we've got to factor in lifting up presents as well.
I think it's really impressive that you were able to go into that level of detail and do that level of research, George. On an entirely unrelated note, how's work for your degree going at the moment?
No comment. Okay, so Stan, another interesting question, perhaps not quite as Christmassy as the last one, was, given antibiotic resistance, do you ever think that we will use bacteriophages to treat infection?
Yeah, no, it's a very interesting question, George. And I think the answer is yes. So a lot of work's been done by guys like Tim Liu and Jim Collins at MIT, who've actually engineered bacteriophage not to kill bacteria, but instead to weaken bacteria.
So what exactly are bacteriophages, sorry?
Yes, good question. So bacteriophages are viruses which have evolved to infect bacteria instead of mammalian cells, for example. And the idea is that you can genetically engineer them so that they can target pathogenic bacteria, which can cause us disease. And this is increasingly relevant considering bacteria becoming increasingly resistant to the antibiotics which we would normally use to treat them when they infect us. And the important thing about the engineering process is that they're actually designing these bacteriophages to weaken and not kill the bacteria. And the thinking behind this is that if your bacteriophage kills the bacteria, that increases the selection pressure on the bacteria to develop resistance to the bacteriophage. And so the idea is that you would use this as an adjunct therapy to antibiotics. So Jim Collins spoke to us about how one of the main ways that antibiotics work, which we didn't necessarily know about beforehand, was inducing this metabolic stress on these bacterial cells. And if you can apply a bacteriophage which increases that stress, it could push yourself beyond the threshold to where you're actually having a killing effect.
And presumably these bacteriophages wouldn't infect human cells.
Yes, so this is the key distinction. These bacteriophages, these viruses, are very specifically targeted to one kind of bacteria. And I think the big question they're answering in this work is, okay, well, how can we develop different bacteriophage which are going to target different bacteria? So George, I've got another question for you. It's quite broad and it's quite philosophical, so I'd be interested to see what direction you choose to take it in. Somebody's asked us, what is science?
Okay, so in fact, I do actually have a dictionary definition in front of me. So science is knowledge from the careful study of structure and behaviour of the physical world, especially by watching, measuring and doing experiments, and the development of theories to describe the results of these activities. So I think that's all very well and good. For me, I think science is about evidence. Science is about how can we make sense of a variety of different things, whether it doesn't necessarily have to be medicine or physics or our traditional branches that we associate with science. But I see science as more of a method. Science is about making these predictions on what's going to happen and working out how we can test our own hypotheses about it. I think science is about being willing to be proven wrong about something when you get given enough evidence. So I think otherwise we're just sitting here with our own dogmas that we won't move on from. So I think you should be willing to upturn your scientific beliefs if something comes around.
Absolutely, and I think that's what makes science sort of unique, in that you can't attack science for being a specific set of beliefs, because it's actually a way of looking at the world which is willing to adapt to new information. So George, I was wondering, what do you think the effects are going to be on Santa of sleep deprivation? So he's traveling around during the night, delivering all these presents. It's a stressful situation. It's one night of the year. How is the lack of sleep going to affect his performance?
Okay, so I can't necessarily comment on how stressed Santa would be. I mean, he does do it every year. But what I can have a stab at is what the effects of sleep deprivation might be. And those depend both on Santa himself and how long he's been awake for. So let's say, Santa's got this all worked out. He's had the entire year to prepare. Let's say he wakes up at a sprightly time of 7 a.m. that morning. And he finishes delivering presents at, say, 7 a.m. the next day. And I mean, given the time zones, you might be awake for a bit longer than that.
Sounds reasonable.
What would be the effects of sleep deprivation, particularly given that Santa is driving? So there have actually been recently quite a few studies done on how sleep deprivation affects us driving. So we all know the dangers and indeed the fact that it's illegal to drink with too much alcohol in your system. But actually, there was one study done in driving simulators that said that staying awake for 18 hours was the equivalent of having a blood alcohol of 0.05%. So that's 50 milligrams per 100 mils, which is the legal limit in Scotland. So just by staying awake for 18 hours, so that's 7 a.m. until 1 a.m. in the morning, would put you on the drink drive limit. And presumably this would get worse and worse as you go throughout the night.
So I'd heard that actually the difference between drink driving and driving when you're sleep deprived is that while your reactions might be slower when you've been drink driving, apparently when you've been sleep deprived, you actually go into like micro sleeps where you sleep for fractions of a second and you literally are unable to respond for that given period of time. Is that true?
Well, I mean, I can't necessarily comment on the studies behind it, but I know that it is a part of Matthew Walker's book, Why We Sleep, which I assume you've read. And actually another interesting point that he made in that book is if you make the combination of having some alcohol in your system and being sleep deprived, the number of mistakes that you make driving doesn't just add up, but they multiply together. So this could be actually quite a dangerous relationship, given that Santa gets offered quite a lot of sherry at different places and probably various other bits of alcohol.
But we've already discussed that. I mean, his body weight is so high, given the amount he's eating. How much does that actually affect his blood alcohol, I wonder? Interesting.
Well, assuming Santa, 21 million kilos. But then this is going to be matched by quite a lot of sherry, for example, at the same time. So we're scaling up the alcohol as well. Even though fat tissue absorbs alcohol quite well, we're putting in quite a lot of alcohol into Santa's system. And also remember that if you're drinking it quite quickly, you put it straight into your bloodstream, and most of the blood that's going around your body doesn't go to your fat. It doesn't have very much blood going to it. So we can make a comparison to general anaesthetics, for example, going off on a tangent. That if you introduce an anaesthetic quite quickly, much more of it is going to end up in the parts of your body that are perfused quite a lot.
Like the brain.
About your brain, your kidneys as well, exactly your brain, where it's actually acting properly to produce these symptoms in your central nervous system. And slowly and surely, it will build up in fat tissue as well. But this takes quite a lot longer because there's not as good a blood supply, which is why that if you're under anaesthesia for longer, you get this longer hangover period afterwards, because the anaesthetic comes closer to equilibrating across your whole body and across all of your fat. Now, if we relate this back to alcohol, I would place some money on the fact that more of the alcohol, certainly at first, if Santa's going around this quickly and he's visiting a single house in a fraction of a second and drinking some sherry, I'd place quite a lot of money on the fact that it's going to be quite a lot of alcohol that's finding its way to Santa's brain quite quickly. So to answer that question, I'm not sure Santa will be in peak physical condition for driving, and perhaps if you see a sleigh flying around, if you're the pilot of a small aircraft, you should stay away from it. So hopefully the reindeer know what they're doing. Okay, Sam, so on to a less serious question. How much of your time does Page a Podcast take up?
Probably more time than I thought it would, but a lot of that is by virtue of the fact I'm not very efficient with it. So I haven't gotten that much better at editing videos than when I first started. And a lot of it, to be honest with you, is admin. It's just emailing people who you think might be interested in speaking to you, waiting for responses, trying to organise times. But it is time well spent because you end up reading about a lot of things which you wouldn't necessarily read about otherwise.
Yeah.
And obviously recording the episodes.
Certainly we're learning. We're learning as we go along. I spend quite a lot of time reading up on questions, but that's actually quite a fun part of it.
Yes, and I think you learn a lot about the skills of how to... Interviewing somebody isn't as straightforward as I had thought it was. And And it's definitely a bit of an acquired skill. Not to say that I have that skill yet. But no, it's a fun learning process. It'll be interesting to see how we keep it up sort of during more stressful times of this year, or when we go to the clinical school to sort of practice in the hospitals and our time is more limited.
I think we've also spent quite a lot of time investing in building up social media, for example, and just working out, like, now that once we've produced an episode, we now know roughly what we need to do.
Yeah, we can go through sort of the set.
We put it on Instagram, we put it on our website, we know how to upload it as well.
And
exactly. This process is happening quicker.
So I was joking about not really learning any of these skills as I was going, which is why I'm not much quicker. But you do actually pick quite a lot up. So the answer is probably more than my degree at the moment.
More than our director of studies would like.
But that's a problem for another time. Okay, George, following on from that, somebody's asked us, do you see yourselves branching out from like medical and biological topics on the podcast?
Yeah, so I think medicine and biology is pretty broad as it happens. So we've done episodes ranging from evidence-based medicine and exercise physiology to kind of mapping the brain and stem cells and diabetes. So I think there's certainly, we're not going to run out of things to talk about there. Mainly, I've often followed things that I find really interesting. So I'll see a topic and I think, oh, actually, I'd love to be able to talk about that with someone. Or I go to a talk and I think, oh, that's great. So yeah, I think I would like to talk about some things outside of medicine. I'm quite interested in perhaps looking at driverless cars. So hopefully we'll be able to branch out. It'll be a bit more of a challenge because we don't have that much of a background in those subjects. But then I guess that's also the case for some of the things we've interviewed on.
So yeah, I think there's so much to speak about within medicine and biology that we've got a lot of material to talk about for a long time to come. That being said, I think we are inevitably going to do episodes which are outside of that, on things which just catch our interest.
So Stan, another nice heartwarming question that's been sent in by one of our listeners is, what have you enjoyed most about making the Phages podcast?
I think what I've enjoyed the most is just the opportunity to speak to people who I otherwise wouldn't have been able to speak to. And that sounds pretty obvious because it is. But even once the microphone's turned off, you end up having very interesting chats with people who know a lot about something, and you get to learn something about that. And it's also cool being able to share that with people who, aren't necessarily spending all their days reading like papers in a given field, but giving people a gist of like what's going on.
There have been some really nice moments where people have come up to me and said, oh, I've listened to your podcast. And I thought, I never expected you to listen to my podcast.
Moments plural or singular?
No comment.
But yeah, so what have you enjoyed the most?
Yeah, I think much the same, actually, just being able to chat to some really interesting and passionate people. It's amazing and actually, quite heartwarming how many people are up for taking time when they're evidently really busy with things to actually chat to someone who they've never met before for podcasts they've never heard about, and actually be so enthusiastic about it. And I love reading up about it and learning all about it and actually then spreading it afterwards. So.
Oh, here we go. So there was one last question. I haven't read this one before.
The final question.
Is it safe to listen to the Phages podcast whilst operating heavy machinery? I've heard it causes drowsiness, so just wanted to check. What do you think?
Okay, so that's a really great and a really relevant question for us to finish off on. Now, I think the first part is the part we need to look at. Is it safe to listen to Phages podcast whilst operating heavy machinery? The drowsiness, I think, isn't so much of an issue. But it's actually not recommended to listen to podcasts and listen to music whilst operating most heavy machinery due to background noise. So according to the US National Institute on Deafness and Other Communication Disorders, long exposure to sounds below 70 decibels is unlikely to cause hearing loss in the long term, but move to above 85 decibels, and that's pretty standard for some machinery as well, which can be far higher than that, and it could cause issues. So in order to actually understand what's being said in these podcasts, it might be actually essential to turn up the volume on headphones, for example, or on speakers to far beyond the safe limit. And the louder the noise, obviously, the less time it typically takes for noise-induced hearing loss to occur. And this is particularly relevant for us humans in comparison to some other species, because the cells in our ear, what are called the inner hair cells, which actually transduce sound waves and then turn them into electrical signals. Once these are damaged or once these die, then they can't be regenerated. So you want to avoid damaging those at all if you can. And quite a few studies have shown that individuals who do listen to really loud music on quite a regular basis do have increased hearing issues, including tinnitus, an increase in threshold as well. The other thing I'd say is actually, because some of the ideas that we're bringing up on our podcast are really, really interesting, it's important not to be distracted whilst operating what can be quite dangerous heavy machinery as well. So whilst this isn't medical advice and we don't have a disclaimer out there, I'd say probably don't listen to Phages podcast whilst operating heavy machinery. And thank you so much to everyone who sent in questions for our Christmas episode. We hope you enjoy it when it comes out. And I think the only thing that's left to say is Merry Christmas.